starting to get a little bit crowded, so we'll see what we can do to make life a little bit easier for you. But we're now coming together with everything. So at this point in time, we should be pretty comfortable with the different ways that a quadratic equation can be written, right? We've got the general form. Why at the end of all of these have I got a cannot equal 0? Pardon? No, not everything would equal 0. But if a was 0, what would happen? It wouldn't be parabolic anymore. It wouldn't be a quadratic. It would then be linear. So it's just politeness to stick that a can't equal 0 at the end. We are now very familiar with the vertex form. Do we agree? And the vertex form is groovy. Why? Pretty straightforward. You can find the vertex. So the vertex here, who remembers? What would it be? Good. I can hear the mumblings. Would be HK. Do you remember what this bit here does? Pardon? Not the flip it, no. Excellent. It moves it left or right. Okay, we call that a horizontal translation. And the thing to remember is that if it is x plus 2 squared, which way does it move it? To the left. Left, left. Okay? The k, if this is a horizontal translation, what is the k? Vertical translation. In other words, it moves it up or down. And that was a little bit more straightforward. When it's positive, it goes up. When it's negative, it goes down. For each of the h and the k, does it actually change the shape of the graph? No. Excellent. What changes the shape of the graph? A does. Fantastic. And how does it change it? Wait, I'm coming to you. Yes?
If it is larger, then it gets like less wide, and if it's
right. When it's large, positive, and when it's large, negative. So greater than 1, less than minus 1, it gets, what did you say?
Like
skinnier?
Skinnier.
Yeah, skinnier, thinner. And of course, when it is in between 1 and minus 1. So give me an example of a number in between 1 and minus 1.
0.5.
Excellent. A half, minus a half, a quarter, 0.1, whatever. Okay? And that would mean that it then gets wider. Agreed? So we have these in our notes, and I'm just going to write one of them. So we've got when a is in between 1 and minus 1, that's when it gets wider. I think the obvious, when it's outside of that boundary, it gets skinnier, thinner. What else does the a value tell us? Fantastic. Concave or convex. So remember, this one is called convex. And this is when it's greater than 1. These should all be in your notes already. As I said, apart from the writing on the board, this is all in your OneNote also. We have then moved on a little bit, and we've started to look at some more aspects of this parabola. So we know the general shape. Now we want to look at, can we sketch it and include some vital things? We want to include the axis of symmetry, the x-intercepts. Did I put the y-intercept? I did not. Yes, I did. Oh, I'm ahead of the game. Right, we want to put the y-intercept. And of course, we also want to include our vertex or turning point. Okay? Now, to find our x, yes?
Why is the y-intercept pointing to the turning point?
Oh, because I stuffed it up. Because in this case, I stuffed it up. I will change that. Well done. So I think my arrow shifted on OneNote. Anyway, good pickup. So we know these things already. Y-intercept occurs when x is 0. Just slap it in. Okay? In general form, if you're ever given it in general form, your y-intercept is bang, that one there. Agreed? To find your x-intercepts, that's when we're solving the quadratic. We make it equal to 0. If it's in expanded form, then we try and factorize it, because that's going to be quick, simple, all is well. If it's given to you in completing the square form, so if it's given as, let's say, 0 equals x take 3 squared minus 7, what would you do? How would we solve that? Would we expand? No, no, no. How would we solve that? Put the 7 on the other side. That's right. And then get rid of the squared. Square root. Come on, people, wake up. And therefore we get x equals 3 plus or minus root 7, right? If you expanded it, you're doing more work. You'd get it back into this form, and then you'd have to do the quad formula, and you would get this answer again. But you're probably taking more time and more effort to get the same result. Does that make sense? So look for these things when it's in this form, solve. Obviously, if that was a plus 7 instead of a take 7, what happens when you pop it on the other side? You get a minus, and you go, oh, can I square root a minus? You cannot, and you go, game's over. This means there aren't any x-intercepts. So imagine that's like one line, you can figure it out, as opposed to you then have to expand, you then have to use a quadratic formula. Oh yeah, I got a negative underneath the square root. So save yourself a bit of time. Correct? Okay, and some of us got a little bit bamboozled last time when we had y equals something, and then all of a sudden the book starts writing f of x. It's just fancy pants for y. It's called a function in x. But same deal, it means y. We happy? And then to get our vertex or turning point, when we've got it in vertex form, we can just bang, say it. If it's not in vertex form, if it's in our expanded version, then we use our minus b over 2a. Does everyone remember that? And remember, it's in our quad formula. If you don't remember, I can see the face. If you don't remember, it's not a bad thing, is it? Minus b over 2a, simples. What does this mean? F of minus b over 2a. This is your x value. You're asking to find your y value. So if I have my x, how do I find my y? Sub. This is just fancy pants for saying take whatever your x value is here and sub it back in to get your y value. But I don't want to write that out in a sentence, so I use shortcut notation. So that's where we are at the moment. We're working through and doing all of this stuff. So 19E is hopefully going to wrap up everything that we've done so far, maybe. All right. 1A, part 1. Find the coordinates of the vertex. Now we have a choice. We can try and do completing the square. It's got an even number in the middle. I mean, it's not going to be that bad, so we could do it. However, we now have this groovy little formula that I can find the x value of my vertex by going minus b over 2a. So minus 4. Happy that I just write 4. 2 times a, my a value I can clearly see there is 1. So we just say it's 2. 4 divided by 2 is 2. 1, 2, 2, 1, 2. Okay, so what we have is we have our x value for the vertex is 2, and I want to find my y value. So that's what that formula was on about when it says minus b over 2a f of. Got to be careful when you say that, hey? F of. F of. So what we're saying now is we want 2 f of 2. In other words, go to your original function, and wherever x is, we're going to replace it with 2. That's all that says. So don't get caught up with the whole thingy. Go, yep, that's fine. I'm going to put it back in here. So it's going to be 2 squared. So I better write that nicely. F of 2. Now, do you have to write this? No. You can, in your head, go 2 squared minus 4 times 2 plus 2, or you can pop it straight into your calculator. 4 take 4 is minus 4, plus 2 is minus 2. And we're done. I wanted to complete the square, you can see I get the same answer, right? Halve it, get rid of the take 4, simplify, and I will get the same vertex of 2 minus 2. So you might go, oh, I prefer completing the square. Go for it. But would you still choose completing the square for something like this? God, no. So the formula, that's my go-to every time. All right? I'll get rid of all of that in a minute. Let's carry on. So we've now got the vertex. Determine whether the vertex is a minimum or a maximum. How would we know that? Hands up. So well done. What Elle's saying is that if you know if it's going to be concave or convex, agreed? And we know that it is convex because that's a positive 1. So we know therefore that it is a minimum. Happy days? Okay, new word for us, the range. The range, they are the y values. So what possible values can your y take? If I was to sketch this graph, here's 2, here's minus 2. We know that it is convex, agreed? Now it's not asking you to sketch it at the moment, so don't get too excited. So this is 2 minus 2. So we're asking, what's the range? In other words, what values of y can exist? So it couldn't be, y couldn't be minus 3, minus 4, minus 5, could it? Yep, what could it be? Has to be greater than minus 2. Could it actually be minus 2?
Yeah.
Yes. So instead of us writing that, we write y is greater than or equal to minus 2. Bang. Love the maths notation. Saves us ink. If it asks you to state what the y-intercept was, I can just look. What is my y-intercept? Yep, well done, Gus. It's 2. What if they ask me for my x-intercepts? I would try and look at it and go, can I factorize it? Could I factorize? Really? No. Factors of 2, that will give me 4. No. I cannot find factorizing, so then I'd either go quad formula or complete the square or calculator or quad formula. And in this case, I'd probably go quad form. Now, it's not asking me to do that, but questions will eventually. And you just put all those bits of information on your graph.